Hey everyone, welcome back to my YouTube channel. Myself, Hima Shankar. I am studying in Sri Venkateshwara College of Engineering in the Department of Computer Science and Engineering. Today the subject is analysis and design of algorithm. The topic I've chosen is warshals and floyds algorithm. So what is an algorithm? Algorithm is a finite time of instructing, uh, designing an instruction for a given problem. So why we are designing an algorithm for a better code? So we design multiple algorithm and choose which one is the better one for solving a thing. So today I have mentioned about Floyd's and Warshall's algorithm. It is a dynamic programming algorithm used to find the shortest path between all pairs of vertices in a weighted graph. So weighted graph is the on the vertices there is given a number that is called a weight of the graph. And directed and undirected is directed means there is a arrow mark from one vertex to the another vertex. It efficiently calculates this shortest paths, including those with negative edges weights, making it valuable for various applications like routing, networking, robotics, etc. Minimum spanning tree is a subgraph that connects the graph's vertices with minimum total edges and with no cycle. So it is an acyclic graph. So Warshall's algorithm purpose computes the transitive closure of directed graph, determines whether path exists between the pair of vertices. Input the Boolean adjacency matrix. So how we give input is ones and zeros. If there is a connection, then it is considered as one. Otherwise, it is a zero. Output a matrix indicating reachability. One is if the path exists, zero otherwise. Floyd's algorithm purpose computes the shortest path between all pair of the vertices in the weighted graph. Use minimum spanning tree for the shortest distance path. A matrix of edge weight can include negative weights, no negative cycle. Output a matrix of shortest distance between all pair of vertices. Why Floyd and Warshall's work? Correctness of a proof. The algorithm relies on the principle of optimal structure, meaning if the shortest path from I to J passes through a vertex K, then the path from I to K and the path from K to J must be the shortest paths. The iterative approaches ensures that by the time of vertex k is considered, all shortest paths using only vertex 0 to k minus 1 has already been computed. By the end of the algorithm, all shortest paths are computed optimally because each possible intermediate vertex have been considered. So now we will learn about step-by-step implementation. Start by the updating distance matrix. By treating the vertex we are possibly making an intermediate node between all the pair of vertices. Iterate through each vertex at one at a time. For each selected vertex k, attempt the improve the shortest path that passes through it. When we pick vertex number k as an intermediate vertex, we already have considered vertices 1, 2, k minus 1 as intermediate vertex. For every pair of I, j of the source and destination vertices respectively, there are two possible cases. K, not an intermediate vertex in the shortest path from I to j. We keep value distance of I to j as it. K is an intermediate vertex in shortest path from I to j. We update the value of distance I to j as I to k plus distance of k to j. If distance of I to j is greater than distance of I of k and distance of k to j, repeat this process for the each vertex k until you reach the intermediate possibilities have been considered. So when we are learning some algorithm, we need to have something beneficial like real life applications in it. So the real life world applications of Floyd's and Warshall's algorithm is network routing. Purpose. The algorithm helps determine most efficient paths for data packets to travel through computer network. How it works? By finding the shortest path between all pairs of nodes in the network is can be dynamically adjust routes when network conditions change, such as a link failure. Example, this is particularly useful in telecommunication networks and internet routing, ensuring faster net speed and minimizing delays. Benefits allows dynamic adjustment to routes when the network conditions change. So, traffic management system, city planners use an algorithm to optimize traffic flow by finding the shortest path between the intersections. It how it works. It can analyze traffic pattern and identify the bottleneck to suggest the most efficient routes for computers. Example, this can help reduce congestion and improve overall traffic efficiency in urban areas. Network analysis. Purpose. The algorithm can help analyze connections between individuals in social network. How it works? By finding the shortest path or minimum number of connections between individuals, it can connected people are. Example, this can be used to understand social influence, identify key influences, and even find the shortest path to connect the someone you want to reach. So, game development. The algorithm can be used to calculate the shortest path for characters to navigate complete game map. How it works, it can help characters avoid obstacles and find the most efficient route to destinations. Example, this is commonly used in video games to create realistic and engaging character movement. Other application, robotics. Robot can use the algorithm to find the shortest path through environment. Public transportation. Public transportation can optimize the routes and schedules. Flight schedules. Airlines can use this algorithm to determine the shortest path from the between the airports. Logistics, the algorithm can be used to optimize the supply the chain routes. AI and machine learning, it can enhance algorithm for decision making. So when we compare, almost the vertices and floyds algorithm both same. So when it comes to the comparison, which is better, so here it depends on what you need. So if the task is about finding if the path exists between two nodes, then warshals is algorithm is the better one. Finding the shortest path with edge weight, Floyd's warshals algorithm is the better one. And another thing, Floyd's and warshals does not work for negative numbers. Thank you for watching the video.